everybody. Here are three theorems. We just, in the previous video, talked about corresponding angles postulate. Remember, postulate is a statement that you have to accept as being true without proof. These three are theorems that actually can be proven from the corresponding angles postulate. I'm going to show you some examples, one of each of these three. The third one, you really want to make sure you pay attention to the third one because the third one is the tricky one that gets students sometimes. We learned about it yesterday, though, on investigation 3.2. First one, alternate interior angles theorem, I abbreviate AI, on page 156. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Okay, so if you look over here at the picture, try and ignore this side here on the right. Okay, here's a picture. And again, these markings mean those lines are parallel. These theorems and that postulate from yesterday only work if the lines are parallel. And so the first thing you have to identify is that these two angles are on alternate sides of the transversal and they're both in the interior. Okay, since they are alternate interior angles and because the lines are parallel, that means that those two angles have to be congruent, which means they have to have equal measure. Okay, so then I go through and I solve it. I get x is 25. Now I got to check, what is it that they want me to find? I didn't reveal that to you, but they want me to find the measure of angle ABD, not x. So I have to plug it back in, take a look at what angle ABD is. It's 2x plus 10. So I plug it into that, plug in my 25, and I end up getting 60 degrees. Okay, that's a typical question. Not easy, but typical. Okay, the next one is alternate exterior angles theorem, which I abbreviate AE. And I want you to use the abbreviations too. AI for alternate interior, AE for alternate exterior, and from yesterday, CAP for the corresponding angle postulate. The alternate exterior angle theorem says if two polar lines are cut by a transversal, then pairs of alternate exterior angles are congruent. So I take a look at my picture. I have that critical piece that these two lines are marked parallel, right? If that isn't marked, you should be saying, Fiedler, I can't do this question because we don't know if those lines are parallel. Even if they look that way, they have to be marked. So I notice this. Here's my transversal. Goes to those two other lines at two different points. This is on these two angles are on the alternate sides of the transversal, and they're both in the exterior, not the interior, but the exterior of those two angles. So x is equal to 125. Okay, so that one was a pretty quick one. Usually these types of questions will involve algebra. Okay, and this one didn't involve too much algebra. All right, here's that third one that I told you about that gets students sometimes, and it was number 4 or 5. I can't remember on the investigation yesterday. Same side interior angles, abbreviated SSI. If two parallel lines are cut by a transversal, then the two same side interior angles are supplementary. And here's how I remember it. Same starts with an S, side starts with an S, so does supplementary. Same side sup is what I hear students say over the years. Two parallel lines cut by transversal, then the two same side interior angles are supplementary. So I look at the picture. Here's that critical marking of those lines being parallel. This is our transversal. They're on the same side of the transversal and they're both in the interior. So it says find the measure angle TUS. Let's find x first. Okay, so the first thing I'm going to do is 13x plus 23x is equal to, supplementary means that they add up to 180 degrees. Okay, move it up a little bit. 36x equals 180. Divide by 36, both sides. I get x is equal to 5. Now I'm not done, right? It says find the measure of angle TUS. Measure of angle TUS is equal to 23x, which is 23 times 5, which is, 115 degrees would be my final answer to this question. So the key thing that's got to stick with you is same side sup. I think that is a definite challenge for students year to year. Thank you.